Hello, this is Mr. Caslin. We talked about coming up with a few system of inequalities word problems to give you some practice for your test. So what I'm going to do is, here's the problem. It has to do with buying two different types of equipment. You're the expert at tennis, so I don't know if tennis balls cost $2 anymore. So we'll see how old this problem is. Anyway, what you should do is work through this problem. Go ahead and set up your system of inequalities. Go ahead and graph it. And so before you do that, go ahead and pause the video. Go ahead and work through it yourself, and then you can check your work with mine and resume the playing. Okay, you should be unpaused now. So this is what I did. Most of these problems are set up with the fact that you have a total number of two things that you're interested in, and you have a total cost of two things that you're interested in. So this one discusses baseballs and tennis balls. Remember to define your variable. In this case, you could let x equal to the number of baseballs you're purchasing. Let y is equal to the total number of tennis balls you're purchasing. If you like your variables to match the words better, so you can track them better, you could say let b equal the number of baseballs purchased, and let t equal the number of tennis balls purchased. So whatever your preference is. All right, so when you're setting these up, you know that so I let x equal the number of tennis balls purchased. So I know $3 times the number of tennis balls I'm purchasing is the total cost for the tennis balls. $2 times, did I say tennis balls or baseballs? But $3 is the baseballs, $2 is the tennis balls. So that's $2 times the number of tennis balls. Now your budget means you can't go over it. You can be equal to your budget, you can be less than your budget, but you can't go over your budget. So this is a less than or equal to $100. So 3 times the number of baseballs plus 2 times the number of tennis balls. It's got to be less than or equal to $100. Okay, so the next is the system. So you need another equation. We have two variables, so we need two equations. You know that you want to buy not fewer than 45. Not fewer means you have to buy at least. That's another way of saying you have to buy at least 45 balls in combination. All right. Now you do actually have two other inequalities in this problem. You can't buy a negative number of baseballs, and you can't buy a negative number of tennis balls. So those both have to be greater than or equal to 0. So when you're graphing it, it puts you in the first, you're only graphing in the first quadrant. Okay, now I'm going to let you solve this. This is now, you've got your system of inequalities here. Those are in standard form. All right, so probably your best bet is to do an elimination on these. Okay, use a multiplier. I'd take this equation here, use a multiplier to get two of these to eliminate. You could do a -3 or a -2. And then solving these isn't too difficult. And then when you graphed it, all right, you should have gotten a shape that looks like this. This is your less than or equal to inequality. This is your greater than or equal to inequality. So the double shading occurred in the middle. Okay, these are in standard form, so you could graph those with your cover-up method using your x-intercepts and y-intercepts. All right, we have a second problem. So I'll let you work through the details, but it's the hard part of these is translating the words to the inequalities. And once you see a few of them, then that's not even really that hard anymore. All right, so the second one, I've got this one for you, so now that you've got the hang of it, go ahead and read through this. Again, go ahead and pause the video, set up your inequalities, solve them, make a quick sketch of the graph, and then I'll show you what I came up with here. Okay, this should be after you paused. We're going to go through the answer on these. On this one, your two unknowns are, you want to know how many hours you're going to work at your cleaning job, and how many hours a week you're going to work at your sales job. All right. You don't want to work any more than 41 hours total, but you want to make at least $254. So you're trying to figure out what combination of hours you could work at each job. Because it's an inequality, you're going to have some options. Okay, so very similar to the last problem. You'll start seeing all these are structured a lot alike. So X must be my number of hours I'm working at my house cleaning job. So $5 times the number of hours. That's how many dollars that week I'm going to earn from that job. My $8 per hour times the number of hours at my sales job. So this quantity here represents how many dollars I'm going to receive from that job, and together I need them to be at least 254. So at least can also be equal to. So if I make exactly 254, that's okay, but I want to make equal to or more than. Okay. I don't want to work any more than 41 hours though. So when I add them together, I've also got school to go to, so I need to work on my schoolwork, so I can only work 41 hours, so it's going to be less than or equal to 41 hours. So I'm trying to find different combinations of hours that I can work so that I'm not working any more than 41, but I'm still earning this amount of money. Okay? I can't work a negative number of hours in either job, so you have these inequalities. These cannot be, X and Y have to be greater than or equal to 0. I mean, it turns out I could work all of my jobs in my house cleaning job and none of them in my sales job. Although the sales job pays more, so more likely I could work all sales and no house cleaning if they've got enough hours for me this week. Anyway, so this is our system of inequalities. Again, I would solve this using an elimination, just eliminate one of these variables by using a multiplier. I could do a -5 or -8. Make sure you're multiplying by all three things. Your graph is going to look something like this. Your graph should extend all the way, you should show it all the way down to the intercepts. But it's going to be less than or equal to this equation and greater than or equal to that one. So all my combinations of hours I could work to meet these objectives would be in this double shaded region. Okay, I hope this helps, and good luck on your final this week. We'll talk to you later.